Hello there, calculus friend. I am going to just show you two examples because it's kind of hard to text about it. So let me just show you these two. So I want to know on this example what a would have to be so that this function is continuous. So I'm going to sketch it so you can see what's going on here. When x is less than 2, so the point of interest is 2, it's going to look like the cubic. But when it gets to 2, things change. And now when x is greater than 2, it's some value which we don't know times x squared. So I know it's some sort of quadratic, which is a parabola. Maybe it's an upside down parabola like that, or maybe it's one that opens up. I'm not sure until I know more about a. But you can see as I drew this, it is not a continuous function. But I want to know what value a would have to be to make this continuous. So this would have to meet like this, or maybe like that. So let's find out what value of a that would be. We learned about continuity, and continuity at a point is defined at this. So the limit, say continuity at point C. The limit as x approaches C, first of all, of the function has to exist. When we learned about that, it had two parts. So for a limit to exist at a point, that means the limit from one side has to equal the limit from the other. When I said equals 0, I didn't mean that. The limit of f of x exists, and from the left it will have to equal the same as the limit from the left. So there's going to, in order for a limit to exist at a point, it has to be the same when you come from the left or the right. Otherwise, we have this jump. So let's look at this one and see what the value, and then continuity at a point goes even further. It says that this limit will actually equal the value of the function at the point of interest. But we don't really have to go that far because all we have to do is meet this condition, and here we will do that. So I'm going to look at the limit of this function as x approaches the point of interest 2, as I come from the left and I come from the right, and I'm going to ensure that they're equal. That will ensure continuity. So the limit as x approaches 2, let's see, from when x is less than 2, so that would be over here from the left, is going to be the limit of this. Remember how you take a limit, you just substitute 2 into the function. So we get 2 cubed, which is 8. So that is the limit from one side. Now we have to ensure that the limit is the same from the other side. So coming in from the right, the function is no longer defined with the cubic, but it's defined with ax squared. And when I put a 2 in for x, I get a times 2 squared, which is 4a. So this value and this value have to equal, so we have a equals 4a to ensure continuity. So a equals 2 on this one. A equals 2, and that will ensure that the function is continuous with no jumps if that value is 2. All right, let me look at one. That's sort of the concept that the problem you're referring to is exercising. Let's look at one that's a little more like the one on your homework or your summer packet. So we're going to do the same sort of thing. I'm not even going to draw it. You can look at what this function might look like on the calculator if it helps you, but we don't need to do that. We just take the limit as x approaches 0 is the point of interest this time, coming from the left will be 4 sine x over x. And the limit, we put in a 0 here. Now we'll let the 4 jump over the limit sign. As x approaches 0 of 4 sine, so 4 already jumped across, we have sine of x over x. Now we can't substitute in 0 there because it would cause a 0 denominator, but we got pretty good at finding other ways to find limits when that happens. So in this case it was a special limit, and it went like this. The limit as x approaches 0 of sine x over x equals 1. So that was just one that we taught earlier in the year, so we bring it out to play now. So we have 4 times 1 equals 4. So remembering that special limit was crucial in this one. Now let's take the limit from the other side as x approaches 0 from the right, and that's a minus 2x. So we plug in 0, we get a minus 2 times 0, or a. So the only way these two can be equal is if 4 equals a. So in this case the answer was 4. Alright, see if that helps you with the 1. I don't have that particular problem right in front of me this second, so if it's vastly different, call my attention to it and I'll do a better job of preparing you. Alright, sounds good. Carry on.